All right. So today is about MLflow, which is one of my favorite topics. You can probably see if you were we were talking shop there for a second. So as always, you can get the code, the PowerPoint, all of the data that we use at this bit.ly link here, the bit.ly intro to PySpark. So feel free to go there. Also, the class videos can be found on my website as well as my YouTube. I don't always get them up right away afterwards, so I do my best, but all of them have been posted as of now. So today I'm going to go over installing MLflow, also what MLflow is, logging, model runs, modeling, talk a little bit about pipelines and grid searches as well. All right. I think somebody needs to mute. I can mute you. All right. Feel free, though, to unmute if you have any questions whatsoever. I also have the chat. Looks like somebody already posted. I think we're good. All right. So just to recap, because I know some people are new to this or haven't been in my last class or in my machine learning class where we've used this data set. So I'm showing here what data we're using. The data includes every admission to a substance abuse treatment center that is publicly funded by the government. So what we're trying to predict would be which admissions were first-time admissions and which admissions were repeat admissions. So if they've relapsed and come back. The goal would be to predict which individuals are at a high risk for relapse upon admission to a substance abuse treatment facility. I have scaled down and randomly selected a small subset of columns from this data set, which is extremely large, so that you guys can save on computing costs. So just FYI, the accuracy isn't great, but part of that is because I'm only using 200,000 rows. So why are you here? MLflow, what is it? So often, and this has become more in demand as of late, as we make all these machine learning models, like what do we do with them? How do we actually use them? How do we put them into production? How do we make sure that they stay accurate over time? Or when we're training 30, 40, 50 models, which is very common, to see which one's the best one. How do we follow that? How do we track it? MLflow is by far my favorite tool for doing that. There are a couple of reasons for that. One, it's easy. It's so easy. Number two, you don't have to use PySpark or Spark or any Spark of any sort to use MLflow. You can use it with R, Python, on your local computer, on Databricks, anywhere. It's a package that is available to the public that you can install just like a Python or R package, like any other one. So one thing about Databricks is they tend to try to make things open source. This is a great example of that. So you can use it not just when you're in Databricks, but anywhere whatsoever when you're actually training a model. I love this because it allows you to log accuracy metrics, log what hyperparameters you're using in your models, so everything you tweak. You can also log feature importances, so if you want to go back to a model and see which features are the most important, you can look at those. It's a fantastic tool. I was actually started a new position and brought Databricks into the company. And one of the problems that I had before we were able to use it was I was training a very large prediction and clustering model. So I probably had 30, 40, 50 iterations of the same model with small tweaks. So without MLflow, I had the problem where I ended up running things, seeing the accuracy, but nothing was being logged. So my two choices at that point were to copy and paste the same code dozens and dozens of times and change one thing in each one of them, which is a huge quality control problem. Because if you're copying and pasting things and changing things, there's a good chance you're going to mess up. Or I would maybe have to go back and rerun stuff, which A, costs the company money, and B, is I could see my sleep ticking away as I would wait for things to run. Oh crap, I need to go back to the old one, have to rerun it. So it was a frustrating aspect. So this completely removes that problem. It gives you an easy area to go in. You can see on a dashboard basically all the models that you've run, whether they succeeded or not, what their accuracy is. You can log anything, files, images, anything. So it's really, really great. Databricks, this is outside of MLFlow, but they work really well together. You can easily schedule and deploy a model in like 5 clicks. So you can go in and schedule a notebook, and I'm going to go through all of that too. And then as it runs every week, you can then go and you can go in and see if your accuracy has changed as your data has been updated. So it's a really great tool. Are there any questions about that? All right. I'm going to exit out just to make sure nobody has joined. We are good to go. So the next thing that I'm going to go through, and I'm going to come out of full screen because I'm going to be flipping between code and the slides here. I'm going to show you, because I'm not sure if earlier in the classes I ever showed how to install packages. I'm not going to teach from this. I'm going to show it, but this is here as a reference if you need to come back and retrace steps if you don't catch this the first time. So this is here as a reference document. So MLFlow, even though it is a Databricks product, it is not natively like installed on your Spark clusters. You have to go in and install it as another package. So the easiest way to do that, there are ways to do this with code and YAML files, and honestly, that is the best way to do it because then you can track versioning, keep your environment the same, but I'm going to stay simple here. So today I have a compute cluster that I started. So I would go in, find whatever compute cluster I'm working on. In general, packages are installed separately on compute clusters. You can't install them on an entire workspace. You have to do it cluster by cluster. And they do that just to make sure things with multiple people working in the same environment that they don't collide. So if you click on this, this is my modeling cluster. To get to the place where you would install libraries from a point and click perspective, you would go into libraries here. So you can see here that I already have MLFlow as well as this params package installed. I'm not going to actually install it, but I'm going to go through the process of showing you how you would do it. So here you go in, click install new. If you're working in Python, you will want to always click the PyPy. If you're working in R, you'll see the cran. If you've worked in R, you probably recognize that. And you'll want to click this PyPy. It really is as simple as putting MLFlow in here and then clicking this install button. I'm not going to reinstall it because it's already there. But if you did that, that's what you would find. You'd see a progress like a spinning wheel here as it installed. And once it was installed, it would show as green as showed here and show as installed. And then you can go and use MLFlow in your cluster. So I'm going to come back. You'll see that I left in all of the notes from the previous class where we went over machine learning in general. They're still in here. I'm using the same notebook, but I added to it to explain the MLFlow parts. I also I have a specific package that are a specific notebook that shows how to register models and actually go in and work with registering your best model once you find it. I won't be running this code because it takes a long time to run. So I'm just going to walk through it and show you the results of when I ran it on a previous time I was in here. So MLFlow will sit down and farther down into the notebook. The top is more like data munging and preparing the data. So the first thing that's MLFlow related for this class is on command 22 here. So setting the experiment name. For you all that have never worked with machine learning pipelines and with tracking and in general MLOps tools, you're probably not going to know what an experiment is. So the idea here, and you'll see this across many tools, Azure ML is the place where I actually learned this the first time, but an experiment is a group of models so that you would group together for organization purposes. It has no other use other than organizing your models and your code that goes with it. So in this case, I'm doing PySpark ML class experiment. So in an actual job setting, this would more be used. So say you do a first iteration of a model and you find some errors in the data and you have to go back or re-engineer some of your features. You could then go in and create a second experiment because your models might be a lot more accurate now that your data is right. So you would create another group to put that in for your more up-to-date, better performing models. Or if you make a major change to your strategy, you could create a new experiment. And that way you have all of your models in different areas so that you know what the bad models or the not performing models and the bad data, they would be separated from this new iteration that you're doing. So you don't have a long list. So that's what's here. Notice that you do have to import MLFlow and MLFlow Spark. If you're using this in Python, you won't have the Spark version. You'll have like the regular Python version. So that would be on more likely on your local computer if you were going to do that. So what this allows you to do is actually set that experiment name and put all your models into a bucket and a separate UI. Are there any questions about that? Kelsey, is that a similar concept to saving models and pickle files? That is part of it. So it stores the models and allows you to restore them and use them. It logs them for use. This is something even totally different. And I think it might be easier to just go in and show you. So I had 2 experiments, like as I said, so I went through, I haven't actually scheduled a notebook. So I was going around, screwing around with this and making this class for you guys. So for instance, I believe I should have multiple experiments. Unfortunately, it looks like it didn't log in there. So it's probably that I'm not knowing where to find it. But beforehand, I tried and went through several iterations of this model, and I kept here the ones that actually worked. I may have just deleted the old ones in general. So I ran multiple models, and I showed how to code these out in the last class, which is posted on my YouTube channel and my website. And there are 2 like regular models that I use for feature selection, the lasso regression and the random forest. And then I just showed a basic grid search with gradient boosted trees. So here you can see that I ran 7 models. And now if I go in, this ended up being my best model. So if I go in and click on this, now I can see at a high level the max depth. It's actually, you can see all your scores down here. I might have made a coding error because the max depth is not showing as an integer. So I probably didn't index it correctly in this particular case. But you can see accuracy, area, the rock score, the F score, precision, and recall. Coming back quickly, this probably has it correct. So my parameters are showing. So this is what you have here. It unfortunately didn't log my parameters here. I think because I didn't have any. It was like the base model with no hyperparameters. So I was able to log all of my accuracy metrics. I also was able to log a CSV with my feature importances here. And now coming back to the question, where it was a pickle file. Is this like that? This is the closest thing to a pickle file in MLFlow. So I'm going to show you the code in a second, but I log my model and I don't even have to save it as a file, but it logs it here. So it actually gives me the code to use this in practice. I did have some trouble getting this to work. So I was not successful, but I fixed it and have a notebook for you guys on the way that worked for me to get this to work, and actually like schedule a model to go through. But we talked a lot about the pre-processing steps in the last class. So all of my pre-processing steps are right here in my pipeline sitting here. We have all of my model metadata sitting here. And we know which packages I've installed. It has a Conda YAML file. And if you're not a Conda person and want to use a pip for everything, you have your requirements text file here. I have MLFlow installed and PySpark 3.1.1, so it can re-engineer your entire environment. And it allows you, and you can go up here and reproduce the run. This is my favorite thing. So if I click this right here, it would spin up a cluster that was identical to the one that I had when I first ran this model. It would go through, and if I ran through my notebook, I would get an identical result to this particular model. It's really super awesome. Sounds like, I see like you love MLFlow. This is amazing, and it's so easy. All of this is super quick and easy to do. So coming back, toggling back on how you do it, now that we know we have showing what it produced. Are there any questions though before I move on to that? How do you actually do this?
You may be about to address it, Kelsey, but my memory from the last class is some of the things you were just showing you had to specify, and I feel like the artifacts were the only part that was there by default. Is that correct?
What do you mean by the artifacts?
Like you were showing the requirements.txt and Conda YAML. I think it stores those automatically, but everything else you had to specify, right?
So it came along with logging my model. So that's what I'm going to get into now. I wanted you guys to understand what MLFlow was. So now that we've done that, now I can show you how to actually do this. And I'll show, and I'm going to break it out into the different areas. So here it talks, in general, instead of using as many slides, unless I need images, there are ways to do it, but you have to point it at a website, and it's a little bit janky to do. So what I'm showing here are, I would say, the structure. So here I'm showing how to log a parameter. So in this case, it would be MLFlow log parameter. I give the parameter name and pretend the parameter is 1. Here, you can set tags for your models as well. So I can tag them if I did something special that I want to remember, or it's in a group of models and I wanted to group that. I would put the tag value. You can tag it with anything. Sorry about that. That's the markdown that I used to create this. And then this is the best part of all of it. So when you're talking about the YAML file, the model files, all of that, this one piece of code creates all of that. So if I log my model, it allows me to reproduce my run. It gives me the YAML file, the requirements text file, my pipeline with all my pre-processing steps, all of it. It just in this one piece of code.
Okay, and to follow up on my last question, without that line of code, you would effectively get nothing. Like it wouldn't even. So basically the default
Correct.
is log the model, reproduce the model, and save the config files.
Yes.
And then everything else, you're that's like the framework, and then you're building on it from there.
Correct, yes. So basically, it's a custom tool where you can log anything you want. So, and these are the main things that you're going to do, and logging those accuracy metrics sits here. And finally, you can log artifacts or files. So the feature importances, I put them into a pandas data frame, exported them to a CSV file, and then logged them as an artifact or a file. So all of that is done, like in actuality, what I showed above was the format that you would do it. So the first thing that you always do is you do with MLFlow, start run. So you'll notice that you're specifying the package, saying to start the run. Then you give it a run name. In this case, I'm doing lasso regression model. So I specified it as a lasso regression model. And then I'm doing as run. So anything after this that you indent will be included in this model run. And then it will automatically shut down the run when you start to do anything that's not indented. So anything indented is going to go into this lasso regression model run. It then goes through. So I wanted to do a tag here, I put my run type as lasso for feature selection. So in my next two classes from now, in my machine learning class, I'm going to be going over feature selection. So we'll go over a lot more about that. But lasso regression is one way that I generally do that, feature selection. So I'm showing it here. And then if you want to learn more about what's going on here, that's in my last class that's on my YouTube channel on how to actually code a model in PySpark. So that's outside of the scope of today. But we put, in this case, the elastic net parameter. So that's basically telling the model that I wanted to be a lasso regression versus a ridge regression or elastic net. That's what that one tells me here. So I'm logging that as a hyperparameter, putting that in here, elastic net, and my elastic net parameter. So I'm going to toggle back since one of my code didn't work. So I want to make sure I show you what that actually looks like. So here, this done correctly, I logged the elastic net parameter and it's now a 1. So when I would go back and do hyperparameter tuning, I would know that in this particular case, the parameter that I logged was 1. So if I wanted to then, with the same code block, run a ridge regression when I made that 0, then I'd be able to see the difference and look at one versus the other. So toggling back to the code. So that is logging your model parameters or hyperparameters. That's what you use that for. I run my model here, came out. I wanted to actually take and run and save my model. So not only am I saving it and logging it, I'm also writing it to a file on Databricks storage. That's just something that I would do just for best practices. I like to do that and have that there. And this log model is what takes the YAML file, the environment, the pre-processing steps, everything, my entire pipeline, everything I would need to reproduce this would show here because of that. And finally, I'm logging my metrics that came out of my model. My accuracy, my precision, my recall, my F-score, and the area under the ROC curve. Last class, I said, when I get to grid search, I'll cover that. But I found a fix for something that I said couldn't be done in my last class. That stay tuned on that. And finally, I wanted to take my feature importances, which are shown here. We're seeing here that the most important feature for predicting relapse in this particular model is whether somebody had cocaine in their system when they were admitted to substance abuse treatment. And you can see that a veteran was also it was very significant in this. Being a veteran was significant in this case. So coming down, those predict that relapse. And at the other end, if you had fewer drugs in your system, the frequency, it would be less likely that you would get a relapse, which makes sense. So all of these are then stored using this piece of code. I took it just like you normally would in Python, read it to a CSV file in my working directory, and then took that path, put it in log artifact, and then it logs that path. And you can see down here that I logged one run, and that shows there. To get easily to all of your experiments, you'll see up here, there's an experiment area. So you can see that I ran a lot of different models, and these were the final ones. And to get to the actual model UI, I can click this, or to get to a specific model, I could click here, but here, go through, it then takes me into the UI that I just showed you, shown here. So you can see here, I actually have my model files. All of that is logged here. I can at a glance see which were my most accurate models. When you do a grid search, the default is area under the ROC curve, but there's a way to actually pull out the best model and also get the F-score, the accuracy, all of that. So now we can see all of those metrics at a glance, and we can see our hyperparameters as well on the different areas. So going to collapse that, you can see my gradient boosted classifier, my max depth getting logged here by the grid search. That's also helpful as well. So when you're running a grid search, it doesn't print out the model accuracy metrics, so you can come in here and see those as well. Are there any questions so far about any of this? All right, so I'll go on to the next topic. So now we have this model. We have all these models. So how do I actually take and deploy that model? We know which one's my best one. We need to get that, schedule it, register it, everything. So if you come into the UI here, I see this is clearly by far my best model. The gradient boosted trees with the max depth, and this is the one where it didn't log it correctly, unfortunately. So I believe this one was a max depth. Yeah, that's unfortunate. But if I come in here, I can see that this model that I have, I could reproduce it. And then you can actually go through and register the model. I'm going to go to one that I haven't already registered so you can see the process of doing that. Come in here. We have our model, and there is usually a register button, but we can come in and you could actually create it here. So you would create a model name. We can do test and create. And you can go through, and no model's registered here yet. Learn more on how to register a model. So if you wanted to come in and do this, I think that because I haven't just run the model, it wouldn't allow me to do it. Usually it'll sit here when you are looking at your model. So come back into our MLFlow UI. So when I went through this, it's probably because I didn't just run the code. There was a register model thing here that allowed me to go through and register that model. So then you would go through the steps and it would put it into your model registration. So if you select here, you could go to best prediction model, which is the one that I registered. I have one version of it. And if I click here, I can see at a glance when I created it. You can actually add a description, any pending requests. You can add a schema, a data schema for that as well, if you want to enforce a data schema as well. So now that we've registered that, we can come in and I want to show now how I would programmatically do that. So how do I find my best model in production? Because yeah, in a case where you're retraining your model, so you put something into production, you update your data, but you want to make sure that your model in production stays accurate. And you're actually doing automated retraining. You're not going to want to go in there, do the point and click solution, or things weren't showing up in the places that I expected them to. So there's a programmatic way to do that too. So say I had a big update on my data. So maybe a couple months of COVID happened and the model changed. So we want to be able to programmatically run this, choose the best model, and update that and deploy it automatically. So here, you can go and get MLFlow, get experiment by name. So I want to pull back that same experiment I've used before. And the experiment name was set up when I actually set the experiment further upstream. So this allows me to get my experiment. And in order to deploy, we also have to get the experiment ID from that. So in order to do that, I pull the ID here. And now I want to search runs. And this will output a data frame, basically. And I can tell it to order by a certain metric. So in the case of almost all cases, you're going to want to probably go with an F score, which is basically kind of an average between precision and recall. So it's the best of both worlds where you get the fewest false positives and the fewest false negatives. So you get something that is a compromise between them. So in this case, I'm going to order my my outputted data frame by the F score. So if I wanted to do this and run this every month to retrain my model, this is what you can do. So in this, I have only the ones that were the best coming out of the grid search is logged, because you can't log every model in your grid search. You have to choose based on what the best one is. And then any model that you run individually, we're going to see metrics on those. If you run a grid search, you will have, for all of those, will have the area under the curve. You can see that's filled in. So in the grid search, that's how I know which one was best. And then it automatically sorts them by the F score. And down here, what I'm doing is basically taking that. It's a pandas data frame, so I can use indexing here. And I pull out based on that data frame. I pull out the best run ID with this code here. So I'm basically finding the first row after sorting. So that's the best run ID. I'm pulling the artifact URI, so that it tells me where my model is stored. So this also shows that up here. It shows the storage area of our logged model. So you can see that here. And then I can actually register a new model if I find that once my data changed, say one of my gradient boosted trees that wasn't better before is now better than the other one. So in order to do that, we would want to create a new model version that would supersede the old one that we had if the other one was better. So we would take we have to set the MLFlow client. I set the model registration name so that you don't have to go in there in the UI, and if something's not showing up, it's not there. You can programmatically do this. And then you would create the model version. So in this case, I took my registration name. This is the source path pulled up here by the artifact with the indexing of the pandas data frame, and my best run ID. That then takes that and it puts that and registers it as a new model version. In real life, you will usually have a staging versus a dev environment, a staging versus a production environment. So you will take an experimental model and push it to staging, and then once it's vetted, you push it into production. In this case, I'm pushing it into the staging area. So we know that this wasn't a fully vetted model, so I'm not pushing it into production. So that allows us to keep our models then separate. So those that are still experimental and those who have been vetted, and if the stakeholders are pulling results from that, it will be not take the place of the production. Kelsey, how do you account for model drift in this model? So this is part of going through and doing the model drift. And so this would be retraining your model. However, detecting model drift is different. So in preparation for that question, this is one of the best trainings I've ever gone to. So they had a data and AI summit. It was totally free. It is every year for Databricks back in a couple months ago. And this goes into, I learned so many things about model drift here. This goes into how you detect model drift, or if your data has changed, because there's more than one type of model drift. So has your data changed? Is the model no longer accurate? So it goes into all those different types of model drift, and then it tells you statistically how you would recognize that it's happening and what you would do to actually fix it. So I could never teach a class as well as this one was done. So I am taking this and putting that in the chat for you guys. I highly, highly recommend taking a look at this if you're interested in model drift. So anyone out there who doesn't know what model drift is, well, it looked like my link sent, but then it didn't. Okay, there we go. Now I think you have it. So any of you that don't know what model drift was from that. So a great example is COVID. So we had all these financial models, all these retail models, and COVID happened and everything changed and models were broken. Just models were no longer accurate. We had all this data that wasn't representative of the current environment that we were. It was different than everything else that had happened before. So if you're doing model drift detection, you would want a way to see that my training data or it has really changed in this case after COVID. So you'd want to be able to send a notification to you or automatically retrain that model if drift has been detected. So that's what this shows here. Data drift is the most common one where you add more and more data, and that triggers that you want to to redo and retrain our models. So definitely recommend this training. Also, just in general, there is an on-demand area. All of these are free of charge. Like, there were so many good sessions, and I have barely even been able to take a stab at all of these, but pretty much everything that you can imagine is here, and you can watch it. I am going to put also the general sessions link up there too, because there's a lot more than just model drift here. You can go through and take a look yourself. I'm a big Databricks fan. That I just showed is a big reason why. So here we've moved our model to staging, we've registered it, we have a new version, all of that. Are there any questions about that? All right. So the next thing is, how do we serve a model? So if we have someone come in that they have a new person that came into a store, a retail store, or in this case, a new person that came in for substance abuse treatment, where we want to know whether they have a high risk of relapsing or not. Maybe we would treat them differently when we onboarded them, or we would extend their stay at the substance abuse treatment if they were shown to have a high risk of relapse. So somebody could then come in theoretically and have it on an iPad. I've built these before, where they would go in, put the different model features in with the patient's information, and then it would spit out high risk, low risk, of whether they were predicted to relapse or not. So in order to do this, we have to serve our model. That particular instance that I just talked about was a real-time scenario, which is not what I'm showing here. That is a whole nother bear. But I'm going to show the more basic. If you wanted to, for a client, you had 50 new customers come in, and you wanted to give them predictions and send them predictions for those individuals. This is what you would do in a batch scenario. So if you had groups of people that you wanted to come in and you didn't need the answers in real time. So now, I believe, predict from registered model. So now I took a subset of our holdout data set. So the thing that the model has never seen before. I just took randomly, I think, 1,000 rows of that just to use as an example. So say 1,000 people came in and we needed predictions on them. So all this is doing here, when I was trying to infer the schema of my CSV, it was not reading correctly, and it was changing strings to doubles and all of that. That's all that's here. So that was giving it and telling it what the schema of my data should be. That's always best practice to do schema enforcement. And I'm going to cover Delta Lake in the next class, which talks a lot more about this. So here, I want to, now I know my model name, so my best model. I want to pull the staging model in this case. And I want to be able to, with my model name and stage, be able to pull the most recent version of the model that has been put into production. So in order to do that, I use the load model, and I dynamically create that path to get to the model with the model name and stage. So nothing is hard-coded here. That's always a best practice in all of these scenarios. As you're building models, you should always be thinking about how you would put it into production and how you would avoid manual intervention by your people. Because if your team is going in and manually running these models each month, that's a lot of sunk time that they're not making new developments and selling new products. So Now, literally all I have to do now is I have my Spark data frame that came in, my subset that I want to make predictions on. I use the same prediction function that I would have used in the last scenario when I taught you guys how to write machine learning models. So I use the transform. And now we have, coming out of this, the CSV model. And at the end, we can pull our predicted probability. We have our raw predictions coming out of this. So predicted probability for each case. You can also pull this out. You'll see that there's an actual prediction category. You'd be able to pull out your predicted probability from this if you wanted. But this is really what you care about. The 0-1 prediction, are they high or low risk? And then you could then read that out to another location. In this case, I have a little teaser for a Delta Lake that I'm going to cover in the next class as one of the areas. And it allows you to do what I did up here. It enforces schema. It does CDC or change data capture. So you can always go back and remake any table that you've ever done. And it doesn't store the whole table. It only stores the changes. There's a lot of great things about that. So next class, if you want to learn about Delta Lake, that's there. It's also lightning fast. So now my stakeholder comes in, they have a group of people, they want to know predictions, high or low risk. I could then pass them this CSV file or do a real-time situation like we talked about, and then they would have those predictions of those people ready to go. And that's what this allows you to do. Are there any questions? So finally, I said that it's easy to schedule this stuff. So we now have something where, say, a stakeholder said, I want updated results of all of my customers every month. But you don't want your team member to have to go in there and do this every month. This is a simplistic example. If you want more information, definitely go to that. But I can create a job here. So if I go in here, create a job, I give the job a name. And in this case, I have used manual because I don't want it to schedule in this particular case and charge me and go on a schedule. But if I wanted to do it monthly, I would be able to say every day, every minute, every hour, every month, every week at a certain time. So if you had a downtime, like overnight, you could do this. So it would be ready on the day the client needed it and your time zone here. Not going to do this because I don't want it to charge me, but you can also trigger a run as well. So this is how you would do something, say, if you had a model upstream where you detected model drift, you could then trigger a run here. So that would then take that new model and do predictions on it. So it's as simple as quite literally going into users. And I could go in to predict from registered model, confirm. Now it's going to run that. You can set how big your cluster you want to be, so that you're not spending too much time, too many resources. In this case, I definitely wouldn't want 8 workers. You can also do a single node if you want and use spot instances, which I highly recommend. And then you can tell it, so if you're doing something in a batch scenario where you're running a bunch of models, you can tell it how many to run at once so it wouldn't overload your cluster. And you can also, you can add alerts in here so that it'll tell you if your model ran correctly, or we could tell it when it starts, when it succeeds, or when it fails, and it will send you a notification, the email that is connected to this particular registration, and then you'll be able to know whether it went correctly. or not. Looks like we got a new question. Could you also trigger a run from Azure Data Factory? Absolutely. So Azure Data Factory is basically, it runs on Databricks as the backend, and it allows you to create pipelines of different notebooks. You can also create more, I would call, simple pipelines within Databricks as well, where you like have a notebook that triggers in order the different notebooks to run, or there are model workflows or notebook workflows that you can do as well. You usually have to go with something like Azure Data Factory when it's a much more complex thing where you are doing a complex there. If then statements, if something happens, then it triggers this. If something happens, then trigger that. An example, we created an image processing model. So for instance, if you had an image that did not clearly read and the accuracy was low, you might want to trigger something else versus another area. That's where Azure Data Factory comes in, complex workflows. We use tags under the advanced options to see how much each department has charged for different projects. Yes, so in general, as you do this and you would implement this in your team, you can see in a different project how much consumption was used, and you can then send that to a different department. So that allows you to trigger it, and I'm gonna not actually do that, but come in and say I wanted to take that and run it now. I triggered a run, I triggered run 5, it's gonna go through, I manually triggered it, it's gonna show up when it's done in this bottom here, hoping it didn't start a new cluster, should be good. So if I go in and I refresh, eventually you'll see that this model, you can see that it's running here. And you could look at the cluster usage, the logs, and even the UI here. So it looks like it's still running. And this is why you would have a notification if you did this in real life. But after a certain amount of time, it's probably going to come down, say succeeded, because I tested it ahead of time. And yep, came down, model succeeded. View details, come in, and we can see here my entire code that was triggered, and the output of it was sent to storage. So if it then failed, if I come back here, a couple of my test runs, I made a couple errors. It showed as failed here. And that you could then trigger a notification where you could come back and fix it. The final thing, I don't think I'm going to get through this today. So I included it in the slides, but I want to know that, have you know that it's possible. So I'm sure all of you have heard of GitHub. If you're on this class, you probably are far beyond at the level where you know what GitHub is. So it is extremely easy to sync a GitHub with Databricks, or you can also use Bitbucket or Azure Repos, I believe, are the free choices. So those are the major groups of Git products that you can use in here. So here you can see that my GitHub has been synced. I synced it in the past. If I come in, I'll show you a little bit about it. Not going to get the whole way through. Let's see, predict from registered model. I believe my Git is synced there as well. So I'm just going to come back in and show you a really old notebook. I'm not going to walk through the full process. But here you can see that my GitHub in this particular case is not linked. So if I wanted to link my GitHub to this particular notebook, I would go in, I would click link, and you would come over to your GitHub. A lot of you probably already know how to do this. You would pull our copy of our URL for the GitHub. We would put that in here. There is a process of going through and registering a GitHub in repos, which is shown over here. That's in the slides. I'm not going to go through it today because we're going to be out of time. But once you register it, it's going to show the dev versus the master branch. In this case, it's going back to master because I vetted the code. And then you would be able to go in and tell it what folder to put it into your Git repository. So you can go in and change where it is actually located. And then I would be able to save this here and it would link to my GitHub. I'm going to come back real quick into my other notebook. All right, so how do you commit in a case where you want to commit changes to a model to GitHub? In this case, I would go to Save Now, and I would be able to type a commit message, so test commit message. It will commit to Git, save it. This will then update in my GitHub, that simple. You'll also notice, and I'm not sure if I mentioned this in previous classes, it saves your code every minute. So the revision history has saved my butt in so many occasions where I could go in and I made a mistake, got to revert. It's all here. All you have to do is click on it and it will take you back to that version and you could restore it if you wanted to. So all of that is sitting in these slides. So there is an overview of the logging metrics, the model UI that I showed, the model registry. All of this information is available for you, showing how to add the token, enable Databricks repos, all of that. So it goes through the full process. There's a lot I didn't show, but if you do want this, this is here as a reference for you guys. The other feel free to get off if you need to, but one other thing that I did want to mention, there is a Databricks certification for the ML practitioner. So it's basically what I've shown in what I showed in the last class previous to this one. So one-hot encoding, how to build models, all of that. So if this one, I would highly recommend doing the associate developer first because it's a much better certification. It's more useful. I learned more from it, but there's also an ML practitioner certification as well. So this would test your knowledge of how to build models in Databricks. It was a lot easier than the associate developer one. So that is here. And in general, there are some certifications that are useless. There's some that are great. Databricks certifications are well sought after. They're going to look really good on a resume. You're going to start getting recruited as a data engineer if you do this because Spark is such a highly sought after skill. If one or two of these go on your LinkedIn immediately, you're going to start getting recruited by company after company. I'm telling you that because if you are looking for a job, this is a really good way to get recruited. You won't even have to try. All you have to do is put Spark or PySpark on your resume and they'll start flooding in. So these are here for you. There's also a Scala one for the developer, but these I can't speak to because I've not taken. But there's also a practice test available now. If you went into the FAQs, it would take you there. Just FYI, because that did not exist before. So there's an FAQs page somewhere. You get to it through here, certification FAQs. That'll take you to a free practice exam because they usually cost money. Databricks gave it for free. And it looks pretty similar to the exam. Like, I went through it, somebody asked me a question over email, and I actually vetted it out. It looks pretty comparable, and it'll show you what kind of questions on there, and we'll be able to target your studying. So I wanted you guys to know that this was here. I talked about certification a little bit in the past, but this is a great way to get a job because out of every skill, maybe other than Python, this actually might even be more sought after than Python because there's so few people who can fill PySpark roles at companies. My last company had hundreds of positions open, and they wanted this. This was on the #1 top of their list of skills that where they had a hole that they needed to fill. And it's like that at any consulting company right now, and at many companies in general, because big data is coming in and they got to have somebody who knows how to use it. So if you're looking for a job, I really recommend doing this. So good luck. And if you have any questions about them, please let me know. Are there any questions before we sign off?
Just a quick question, Kelsey, about the revision history. Did you get that only because you linked your Git, or do you have it anyway?
You have it anyway.
Okay.
Yes.
Thank you.
So it does it regardless. I think it stores it in Databricks storage, or possibly in blob storage that's connected to Databricks. I'm not 100% sure on that, but that'll be turned on, Git or no Git.
Okay. Thank you.
Yeah. Can you please put the certification link in the chat? Absolutely. So I'll give you the links to all of them. The top one, Associate Developer for Spark, Apache Spark 3.0 is your best bet. Like that one's really a good certification. I would highly recommend, and you'll see this, it's very coding syntax heavy. So you need to know what the different functions, what order they would go in, and how they would go into the functions, and what they do. Also recommend using a large monitor because they give you a list of the documentation. So if you have a couple of minutes to spare, you'll probably only get to do this on 5 or so questions. But at the end, you'll be able to go through, and those ones that you were really unsure of, you can actually check in the documentation with any remaining time you have left. I didn't do that and ended up squinting, and then they yelled at me because they thought I was cheating when I was really just trying to read really small print. So highly recommend using a big screen for this. But yeah, and if you guys have any questions about that, please feel free to email me. I've put it in the chat before, but I will put it in. I may not get back to you right away because I'm pretty busy with my job and everything, but I promise I will get back to you eventually. Any other questions? All right. Thanks so much, guys. Appreciate your time. Hope it was helpful.
Thanks, Kelsey.